Hey guys. So, I know I'm not here today. That's okay. We can still do our lesson. Remember, I'm not there on Thursdays no matter what, so I will see you guys again on Friday. But we are still going to treat this as if I were in class, if I were teaching. So, you are still going to do a lesson. You are still having notes that you're copying down. Um, they should have been passed out to you, and if they have not, please pause the video and ask Mrs. Malaznik to pass out today's notes. Otherwise, let's get started. You still have just a warm up and our normal agenda and our normal planner stuff. So I did leave people who turned in their algebra builders to me. I did leave those to be passed out. And so if you do not have yours, again, pause the video and ask Mrs. Malaznik to please pass that out if it hasn't happened already. Otherwise, you are going to get started with your last two sections of your algebra builder. Now, I gave you two of the vocabulary words for the section here, for the vocab section right there. So please make sure that you automatically fill in the rational number and the ordinal number. And you do need to figure out the remaining three. And then you have to work on the equivalence. And remember, that is a decimal and the percent. So for some of these, I will fill it in for you. Like I will fill in 3/5 for you. And I will also fill in 1/3 for you. Please, for now, try what you can. Pause the video and unpause, and we're going to go through the answers. Okay. Hopefully, you attempted it. If not, because you got stuck, it happens. Fill in the correct answers. And then you are keep this paper. You want to keep your algebra builder number 6, so it helps you finish your number 7. Let's fill in your blanks. Let's see what you got. So our first definition says grouping symbols, exponents, multiply and divide, add and subtract. That was order of operations. Oh my. I'm going to run out of space. Your second one says any natural number and 0. Natural numbers, just say, is actually positive. So when we talk about natural, we talk about positive numbers. You can kind of relate it to nature. In nature, you never really see a negative number happening. Like on leaves, you can count the number of leaves. That's a positive number. You can count the amount of petals on a flower. It's a positive number. So it's considered a natural number. And that's just a way you can remember it. Natural is kind of like what occurs in nature. And in nature, those are actually positive numbers because you have the ability to count them. And if it's a positive number and it includes 0, we're going to say this is our whole number. I'm going to run out of space. I'm just going to use the number sign. The one I filled in for you is a rational number, and that is a number written as the quotient of two integers where the denominator is not 0. Quotient is also fractions. Fractions are division questions. The answer to division questions is the word quotient. Next one says a number that cannot be written as a ratio of two integers. Well, if the one before it was, a combination of two integers, something that cannot be written with two integers is an irrational number. And the last one's filled in for you. An ordinal number is a number defining a thing's position in a series. The way you can remember ordinal is kind of like it almost has the word order. So it's kind of like order. Ordinal is like the order, And so when we talk about defining a thing's position in a series, that's like the order in a series, just putting them in order. Let's go down to your equivalence section. I'm going to do these two that I circled for you. 1/3 as a decimal is 0.33 repeating. Now you could write it as just 0.3 with the repeating line. You could write this 0.33 with the repeating line above the threes. It really doesn't matter because it's the same thing. So I'll kind of write your other option. It's just 0.3 repeating. As a percent, you start with the decimal. So to make decimals percents, you move your decimal 2 times to the right, which gives me the whole number of 33. But because the decimal of 1/3 is actually repeating, and it's just the fraction 1/3 repeating, we say this is actually 33 1/3%. If that doesn't make sense, what I'm going to do is just rewrite 0.3 repeating and add a couple of decimal points. I'm just going to say ... So this is only if you're confused. To make a decimal a percent, we move our decimal 2 times to the right. So that's 1, 2. That leaves me with 33.33 ... Well, if I just use these 4 numbers and make it a fraction, the numbers in front of your decimals are your whole numbers. The numbers after your decimals are fractions. So this would be just say 33, and it's in the hundredths spot. So you could say it's like 33 over 100. You can make that a lot nicer looking if you only want to use 1 decimal point. So you could say or 33 and 3/10 if you want. You can estimate it, but since 33 repeats ... threes repeat ... that is really just a fraction 1/3. Any of these would be actually very acceptable answers. 2/3. I know I wasn't going to do that one. I do want you to add in one thing. You need to figure out your decimal, but your percent, I will tell you, it's going to have a whole number, and then it does have another fraction of 2/3. So fill in decimal and then the whole number. Make some space. Last one I'm going to do for you is the 3/5. When I don't know what is going on with fractions, if I don't know what it is as a decimal, it's long division. So 3/5, to make it a decimal, I divide. Top number divided by bottom number. What does that look like? That means I draw what I call a division house. The first number, the top number, goes inside your house. The bottom number goes outside. 5 cannot go into 3, so I put 0 up top. 0 times 5 is 0. I subtract. Because I have a remainder, I don't like that. When you have a remainder, you add a decimal at the top of your house and a 0 on the inside and bring it down. 5 can go into 30 perfectly because it goes in 6 times. And so my decimal equivalent of 3/5 is 0.6. If I want to make 0.6 a percent, I'm just going to kind of write that one out. I move my decimal 2 times to the right. 1, 2. I do need to fill in my empty little loopy loop with a 0. So this is really 60%. Fill in the rest of them. The rest of them are pretty easy decimals. And then we are going to move on to our actual notes. Oh, actually, before we do that, let me remind you, planner stuff. So tomorrow, you have your functions homework number 2 is due. If you were gone yesterday, I did leave extra copies with Mrs. Malaznik, so please ask her. Or it's on Schoology. And then Friday, you have your algebra builder due. If you haven't already, please make your Delta Math account. I need that done because Friday we're using Delta Math. Okay, let's go to our notes. So this is the piece of paper that you should have gotten from Mrs. Malasnik. And again, if you have not, please pause the video, raise your hand, and politely ask Mrs. Malasnik to pass it out. You are going to glue this into your notebook. And then please return your glue sticks. Smiley face. Okay, so our lesson, and if you need to pause the video because you're gluing stuff in, that's fine. But when you're done, just unpause it. We are learning about something called a discrete and continuous domain. Last week, when we were learning, we started to learn about our functions and we started plotting points, either from our coordinate points, from the table, from a mapping. But we were plotting points on the X and Y axis. And some of you wanted to connect them. And sometimes it made like a funky shape. Sometimes you just kind of connected it however your heart desired. Sometimes it made a line. And I said, do not connect them. And you'll find out why. Well, we're finding out why now. You can connect them sometimes, and then you cannot connect them other times. And it's based off of their domain. We have something called a discrete domain, and this is a set of X values that consist of only whole numbers in an interval. I'm going to have you add one thing. If you have a discrete domain, do not connect dots. When you're trying to figure out if you have a discrete domain, we're going to ask ourselves the question below. Does it make sense to have an X value that is a decimal, oopsies, that should say or, not of, or fraction? So if you can have a decimal or you can have a fraction, and you answer no, then it's discrete. If it is continuous, this means it is a set of X values that consists of all numbers in an interval, including decimals or fractions. Continuous means it goes on forever. You know, if I have something that's continuous, it just keeps going. It also means I'm not stopping anywhere. I am including anything I possibly can, which means you will connect your dots. So I'm going to say connect dots. It's really strange to kind of hear these two different words, but it makes sense once we see the other problems. Let's go to the first section. It says describe the domain and range, and is the domain discrete or continuous? So the first thing I'm actually going to do is decide if it's discrete or continuous, because it's a graph, which means it's a lot easier to see. Discrete said do not connect your dots. Continuous means connect your dots. So on the first one, I can see that I just have these individual dots plotted, so that just means it's discrete. So somewhere down here, you can just write discrete domain. And I am just going to quickly answer that on number 2 as well. On number 2, what I see is like, hey, yeah, I see these two dots kind of here on the y-axis, one on the x-axis, but in between those two dots, it's just a smooth straight line. That means our dots were connected. which makes this a continuous domain. If we continue with this question, it says describe the domain and range. That means tell me what it is. So I'm going to say D equals and R equals. Remember, we practice using our squiggly wiggles, which is actually called the brace or a fancy like parenthesis. I didn't do that very well. So domain is related to the x-axis. So when I'm talking about the domain of this particular graph, I'm actually looking at just the coordinate points because they're not connected. Discrete means it's not connected. It's only whole numbers. So we're looking at the x-coordinate of each of these points. If it's easier for you to write out the coordinate points, do it. So I'm going to do that just in case. Going top down, our first coordinate point was 0, 5. Then we had 1, 4. Then we had 2, 3. Then we had 3, 2, 4, 1, and 5, 0. X, then Y. So my domain includes the numbers 0, 1, 2, 3, 4, and 5. The range are your y values. So because I wrote out my coordinate points, I'm just listing my y values.
Kira Meredith to the front office, please. Kira Meredith to the front office.
And squiggly wiggle. Go in order. So this time I'm actually going to go bottom up because going in order means small numbers to big numbers. And I look at my y values. They're actually the exact same as the x. 0, 1, 2, 3, 4, 5. No repeats. And that would be it for number 1. But number 2, if we figure out domain and range, it's a little bit different. So remember with our domain, if we have a straight line like this, we are going to first start and look at where does it cross our x-axis. So it crosses right here. I'm going to look if there are x values that are more than it or less than it. So does it go past this dot? What I see is that my line does not go past my x value of 5, which means I don't have an x value of 6. I don't have an x value of 7. It stops at 5. But it does have x values before it. How do I know? Well, if I look at just the label of 4 and I follow it up, there's a dot on my graph. If I look at the x value of 3 and I follow it up, hey, look, it's hitting my graph. So where do my x values actually start? All the way back here, technically at the x value of 0. So if I follow it up, it hits my graph initially. So my domain is stuck in between x value of 0 and x value of 5. So we write that using our inequality symbols. We started at 0 and we say less than or equal to x because x is stuck in between. So I use another less than or equal to, and then we say 5. This is saying your domain, your x values are stuck in between the number 0 and the number 5, which is very true because every one of those numbers hits our graph. I could even go to a decimal. Here's like roughly 0.5. If I follow that up, it still hits my graph. 1.5, follow it up, still hits my graph. Let's talk about your range. Range or y values. So great starting point is just looking at where does your line cross your y-axis. So I recolored my dot right there. I look at does my line or my shape go above that or below it, and it goes below it. What does that mean? That means for every y value, if I follow it over, it is hitting my line. But my graph does not go on forever because there are no arrows. So my y values, very similar to my domain, are stuck. they're stuck between a y value of 5 and the last y value of 0. So our domain and range happens to be the same. 0 less than or equal to y less than or equal to 5. It is a coincidence these are the same things. Let's really get into how do you know discrete or continuous if you don't have a graph. If you just are given tables, if you're just given a word problem, how do you know? Discrete and continuous domains are where you actually see things in real life. So if we are talking about a domain, I'm only looking at the x values. So for anything, we are talking about the input values, which are your x. So on questions 3 and 4, when we decide if it's discrete or continuous, I don't care what the output is. I don't care what the y is. I only care about x. So I want you in questions 3 and 4 right now, circle the x column. Domain is related to x, which means if I have a discrete or continuous, I only look at the x values. How do I know if it's discrete or continuous? I go ask the question that's written above. We ask ourselves, does it make sense to have an x value that is a decimal or a fraction? So on question 3, our x value is talking about years. So when we ask, does it make sense to have a decimal or a fraction when we talk about years, that's in real life, everyday life. In our table, it's only giving us 1 year, 2 years, 3 years. So we kind of have to add in our own values. So if I off to the side and just say maybe 1.5, 2.5, does that make sense? So in real life, can we talk about 1.5 years of our lives? Can we talk about 2.5 years of our life? Could we talk about half a year, 0.5 years of our life? Think about that for a second. In years, half a year means 6 months. 1.5 years means 18 months. And we can continue to do that for our other values or any other ones that we come up with. So in real life, yeah, I can have half a year because that's 6 months. We can talk about something that happens in 6 months. We can talk about something that used to happen 6 months ago. We can talk about 18 months. We can talk about 2 years. We can talk about 3 years. So yes, it makes sense to have decimals. So if you can say, yes, it makes sense to have decimals, then you actually have a continuous domain. Let's see about number 4. Number 4, our x value, our input, are belts. It's the number of belts. So the thing that holds up your pants. We're going to ask ourselves the question above. Does it make sense to have an x value that is a decimal or a fraction? So if I go to the store, say I go to Target, and I look at their belts, and I'm like, ooh, I like this one belt. I like these 2 belts. But can I go check out and say, I actually only want to buy half a belt? I can already hear some of you probably going to be like, yeah, you just cut it. If I go to Target and I go to check out and I say, I'm only going to buy half a belt, and I take some scissors out, they're going to look like I'm crazy. They're going to think I'm crazy. Because no, I cannot just go buy half a belt. Can I cut a belt? Sure. I still have to pay for an entire belt. And they're going to look at me like I'm crazy because why would I want half a belt? Or why would I want 1.5 belts? Why am I cutting anything in half? I don't need that. And I can't go buy 1.5 belts. I can go buy 1 belt. I can buy no belts. I can buy 4 belts, but I cannot buy a decimal amount of belts. So, because it does not make sense to have decimals, we say this is a discrete domain. Question 5 says, the function b equals 25 minus 2.5n represents the balance b in dollars on a prepaid phone after making n phone calls. Is the domain discrete or continuous? And then it says explain. When it says explain, we are actually going to write a sentence with a capital letter and a period. If I'm trying to figure out discrete or continuous, I have to know, what do you think my x value is, or what is my input? So I'm just going to write off to the side, input, question mark. An input is what we're trying to put in to figure out an output. So we're talking about money after making calls. So what's affecting my money is how many calls I am making. That affects how much I'm spending in dollars. So my input, what is happening, are the phone calls. So input over here, I want you to say phone calls. So I need to know, does my phone calls, can I talk about having 1.5 phone calls? Can I talk about making a half a phone call? Can I talk about 2.5 phone calls? So if you're on the phone, you're talking to your friends, and you're like, oh yeah, no, I'm kind of over our conversation. I'm just going to hang up. That was still 1 phone call. It could be a short phone call, but it was still a phone call. It was a single phone call. It doesn't matter if it only lasted 30 seconds. It doesn't matter if it lasted 2 hours. I made 1 phone call from answering to ending the call. It is 1 phone call. I can't have half a phone call. I can talk for a short amount of time, but that's not what it's asking me. It's asking me for the amount of phone calls. So every time we call and end a call, that's 1. I make another call. I end the call. That's another. I cannot have half a phone call. So we would say this capital letter is a discrete domain because we can't make half a phone call. Period. Your next question, same idea. It says the function y equals 1.6x converts distance from from x miles to y kilometers. Is this discrete or continuous? Explain. Now, what's really nice about number 6 compared to number 5 is that the equation is in x and y. So off to the side, when I write input, question mark, input is your x. So x, talking about miles. So we decide discrete versus continuous by asking ourselves, can we have maybe half a mile? Can we have a quarter of a mile? Can we have 1.5 miles? Think about that for a second. Does it make sense to have decimals and fractions when talking about distance? Hopefully, you say, yeah, it actually makes sense. Because think about people who do track, who do cross country, who just run for fun, who ride bikes, and you're driving. All of that for us is measured most of the time in miles. Sometimes it's in feet if you don't run very far. But most of the time we talk about miles. So I could go walk half a mile. I can absolutely do that. I could go run 3.5 miles. I could run or bike a quarter of a mile. That's true. That's very realistic. That absolutely happens. So it makes sense to have decimals. And if it makes sense to have decimals, then we have a continuous domain. So your sentence is going to be, this is a continuous domain because we can have, I usually like to say half because it's an easy decimal to kind of picture, so I'm going to do that again. We can have half a mile. Oh, I don't know if I want to say half. Let me say, instead of saying have, let's say travel. So we can travel half a mile. Because travel could be us walking, it could be running, it could be biking, it could be driving. Just a little bit better way to say this. Last question, number 7. It says you buy cards to send to family and friends for their birthdays. The function y equals 2.5x represents the cost y of the number of cards x you buy. So our input is x. Again, I really like this one because it includes the variables that we're pretty used to seeing. So our input is actually cards. Once I know that, now I'm going to read the rest of the question. And it says, is 8 in the domain? Explain. Remember, explain means you're writing me a sentence with a capital letter and a period. So to decide, is 8 in the domain, we have to decide, is it discrete or continuous? Because that matters. The fact that it's a whole number could mean something to us. Let's see. So off to the side, we're going to just decide if it's discrete or continuous before answering this question. Well, if our input is the number of cards I buy, so think about that, like birthday cards, anniversary cards, get well soon cards. If you go to the store, you go to Walgreens or you go to CVS and you're standing at the card section, and you're like, yeah, I really like this card, except I only like the front of this card, and I like the inside of another card. I can't just go rip those cards in half and go up to the cashier and say, I only want to buy this part of the card. Again, just like the Target example with belts, they're going to look at you like crazy because, one, you ripped their card, so they're still going to make you pay for the entire card. Even though you may not like the entire card, you only wanted that front cover, they're still going to make you pay for one whole card because you don't get to rip it and only pay for half of a card. So if they look at you like you're crazy saying, I only want half of my card, that means it's not realistic. It is not possible to just go buy half a card. You have to buy the entire card. So this just means, off to the side, it means it's a discrete domain, which means you can only have whole numbers. So when we go back to A, where it asks, is 8 in the domain? This is asking you, can you buy 8 cards? Question mark. Well, yeah, I can go to Walgreens, or I can go to CVS, I can go to Target, wherever, and I can go buy 8 birthday cards if I want to. That's a lot of cards, but I can absolutely do it, and no one's going to think it's weird. So is 8 in the domain? Yes, comma. 8 is in the domain because we can, I'm going to say realistically, buy 8 cards, period. Last one in our notes, part B, is asking, is 40 in the range? Whoa, we haven't seen anything about range this entire lesson. That's interesting. So when it's asking, is 40 in the range? Range is your output / y. In order to decide if if 40 is in the range, you need to decide, is the input value, the x value, possible? So off to the side, I want you to write, is the x value that outputs 40 in the domain? Question mark. So in order to decide is 40 in the range, we have to decide, is the x value, the input, actually part of our domain? And remember, it's discrete, which means it can only be a whole number. How do you figure it out? Well, we use the equation. So off to the side, I want you to write y equals 2.5x, because that's the equation. The output, or y value, is related to the range, which means the range in this question, or the y value in this question, is 40. So what I'm going to do is, instead of writing y, I'm going to plug in what I think the y value is, which is 40. I bring down 2.5x. What I'm trying to do is actually solve for x. It's a one-step equation. How do I do that? Well, 2.5x, this is actually secretly glued together with a multiplication symbol. So what I'm going to do is undo the glue of multiplication with its opposite of division. So I'm going to divide by 2.5. Bring down your x. Now we're going to do 40 divided by 2.5. I know some of you have your calculators. I know you have your phones, but you need to at least practice a little bit. How do you divide? So I'm going to show the long division. 40 would go in my house. 2.5 goes outside it. We cannot have a decimal on the outside of your house. So I move it one time on the outside, but if I move it one time on the outside, then on the inside, I move it one time, which actually makes this 400. So what's the question I'm actually dividing? I'm figuring out how many 25s go into 400. Fastest way to do it. 2-digit number. First, figure out, can it go into the first 2 digits? So can 25 go into 40? The answer is yes. It can go in one time without going over. 1 times 25 is 25. From here, you're just doing normal subtraction. 40 minus 25. Can't do 0 minus 5, so I borrow, and I end up getting 15. Bring down my 0. Can 25 go into 150? Well, here you could just count by your 25s. If you do that, it does go in perfectly. It can go in 6 times. So what does this mean? This means the x value, my input, is 16. So I'm just going to draw an arrow, and I'm going to say input. So is 16 in my domain? You bet, because it's a whole number. I could go buy 16 cards. And if the input is in the domain, that means the output is in the range. So this was a lot of work to now say, yes, 40 is in the range because its input, parentheses x, is in the domain. Period. A lot of work for that last little bit. What are you doing now? Now you are finishing yesterday's homework, if it's not done. You can finish Algebra Builder Number 7, if you do all of that, then you are just on Zern. I will see you guys on Friday. Be good.